Hello people, John Shaughnessy here, trying to describe my law of gravity, Shaughnessy law of gravity 3, that the equation is AMC squared divided by dB. You can see that. Angle of the mass in tons, speed of light squared, divided by the distance, and B is the gravitational constant. Remember, the moon runs everything on the planet Earth as far as gravity is concerned, and there is gravity. Until the electric boys out there can figure out radiation, you can't be throwing the baby out with the bathwater. Anyway, I can understand their frustration. So anyways, I'm going to go over a couple of discoveries I made, and that discovery basically is that 70% of the mass on the planet has mass located 180 degrees away from it. So you got a mountain range over here in the Himalayas 180 degrees away over in America. You're going to have, and on the same approximate latitude, you're going to have some mass. Continents line up with continents. Australia lines up with South America. See, it's 180 degrees away. Boom, they're there. Basically, what's going on is if you have mass on this side of the planet, it's going to lower the gravitational field on this side of the planet and allow mass to rise up and balance it out. We're all familiar probably with a car tire. You're going down the road, you get a little hopping going on the front end there. The tire's out of balance. You bring it in the shop and they put a weight on it. Well, gravity and its own infinite magic, or mechanics. It's not magic, it's mechanics. Basically, it has a self-leveling mechanism to it. So, that being said, I'm going to show you some obvious anomalies here. This is a 3D globe, pretty cool little thing. I've got it on eBay. Might as well go to Giza first. There's pyramids of Giza, 180 degrees away, which is basically right up and over. Or you could draw a line like this way, 180 degrees away. You end up in the the Hawaiian hotspot. So I'll make a nice pyramid here. I'll make a volcano. Alright, it's a Hawaiian hotspot. Now, Giza is like right up here, 180 degrees away. But because we're on a soup sandwich, basically everything on the planet's liquid. Everybody wants to, everybody's like, well, if you have some kind of a theory, it's going to be exact. It's going to be the exact latitude and the exact, 180 degrees away, or otherwise it's no good. Not so. It's a like I said, this is a moving. You get centripetal forces, everything else. I mean, you could potentially be cutting through the Earth's crust up here on latitude 30 and get down to latitude 22 and start pushing magma out of the Hawaiian hotspot. Okay, just keep that in mind. It's a liquid planet. We're going to go to that's 180 degrees away. That's Hawaii, Giza. 180 degrees away, 360 degrees is the planet, so 180 is half the planet, and on the same approximate latitude. Another alignment is Shen Pyramids up in Shen, China here. Maybe it's down a little further. I'm not. Maybe it might be down here somewhere. But anyways, you go up and over the pole, 180 degrees away. You end up on the super caldera called the Bermuda Island, which is made up of two extinct super calderas. So that's a volcano, big volcano. It used to be. It's dormant, but nevertheless, those pyramids line up with it. Another big pyramid alignment here would be, I think it's Pyramid of the Sun. 180 degrees away, we're over in Sri Lanka, right? Oh, I keep doing the wrong one. Sri Lanka. And there's an extinct volcano with a magma plug in it over there. It's called Mount Sigeria. It's pretty cool. Magma plug. It's got those big giant claws over there. Very ancient site. So with that, I mean, those are like the three big pyramid volcano alignments. I mean, there's hundreds of them, literally, people, hundreds of them. There's like 300 pyramids in this area alone, from North, South America up to Mexico. 300 plus pyramids. Now pyramids in and of themselves do three things. They lower the gravitational field under it, so they can pull magma up with the moon's energy, pull ground up with the moon's energy, gravitational field. It's a lensing mechanism. And it could also raise the landmass that it's on. If you look at all the pyramids around the world, the elevation that the pyramids are on are actually a lot higher than, or they're elevated. It might be, within the area, they're generally the highest, land around. But that's not, it could be a mile away. You could have something that's 3,000 feet high, but what I'm saying is that the elevation that the pyramids are on have been, after you build a pyramid with the moon's gravitational pull and release, you'll raise that land because you're lowering the gravitational field there. Now, that being said, why don't we stay here in Mexico? I'll draw this off of here. We're going to go and look at how continents line up with continents. Shapes of continents line up with shapes of continents. They're very uncanny, amazing. All right, you got like more of a triangle type of thing here. That looks like the shape of India. Well, surprise, surprise, 180 degrees away, on the other side of the planet, same approximate latitude. We come over and bang, smack dab, we're on India. With the triangle shape. So this, in essence, Asia lines up with the Americas, somewhat of it. I mean, Asia's monstrous, America's only got 3 time zones. This thing's got like 11. But, this is an older landmass. It's the mountains here line up with the mountain regions of America. Sierra Nevadas, the Rocky Mountains. So anyways, the landmass lines up with landmass, 180 degrees away, same approximate latitude, same as the pyramids and volcanoes. This is like the big window. Hey, everybody, look at this. These things are lining up. So what's the biggest connection? Is gravity. What's everything in the universe, as far as large mass planets and stars and, giant, mass in the universe all want to, and they get into a balanced spherical type of shape because gravity has a built-in mechanism to it to balance out the shape, balance it out, and also weight-wise, and also balance it out shape-wise. So that being said, this would be like, if that's Mexico, this would be like Florida over here, although you're not seeing it really tie into, if the water levels were in the middle of an ice age, this landmass would probably be attached. So this would be like Florida, maybe not that low, this would probably be Florida up here, but this might be Cuba. But anyways, you'll see these landmass. This would be Central America right here, and then this would be South America, Australia lines up with South America, so we're going to spin over 180 degrees away. Here's Australia, there's almost some of the shape, that looks like a shape of Western Australia, I think. So anyways, 180 degrees away, same approximate latitude, you're looking at Australia. Like I said, if in the middle of the ice age and the water level is 500, 600 feet or 1,000 feet lower, this will all be landmass. It would be very, very identical. Not verbatim, but pretty close. But you get the picture. This landmass lines up with South America. A lot of islands around the planet line up with islands 180 degrees opposed to each other, on the same approximate latitude. You just pick an island here out in the middle of nowhere, and we'll go 180 degrees away, boom, and you're on an island over here. It might even be like a a mountain here or something like that. Antarctica lines up with Antarctica. I love that one. That's easy enough to figure out, huh? There's pyramids over here, there's mountains over here. or vice versa. I'm not sure. I'm looking at this backwards, but you know, I've also another discovery I have is the ice-free Antarctica actually resembles a hexagon. If you check out my work on YouTube, I got a picture of it, but it's unbelievably. It's much more accurate than that because it shows the ice here. But ice-free, it's a unbelievable connection. So we're you know, I mean, it's just a lot of connections all over the planet here, with mass lining up with mass. So you got Australia, Asia lines up with America. Now Africa is like the odd child out. It's like the third continent. I know there's a lot more continents, but you know, third landmass, if you will. And again, if the ocean was lower in the South Pacific, all these little dots would be above the ocean level, and you would basically you know, have that landmass lining up with South Africa. And this, of course, is lining up with Giza on the other side. So you have, I mean, there's there's ranges here and there. There's mountains in the Sudan. I mean, there's a lot of you know, mass above the ellipsoid, they call it. So basically, the way gravity works is it's latitude by latitude. So it's, you know, if you get something on this side over here, grows, this side's going to grow something up on on the opposite side. It's going to lower the gravitational field, and it's going to allow magma to burn its way right through the plate and have volcanoes line up with whatever's over here. This is how the planet has been formed. Originally, it was a water planet. You get into Genesis, it was water, and what created the first mountain was ice. Ice built up on, say, the area of North America, which wasn't there. You had ice build up over here in this area. Massive chunk of ice, right? You know, just because it, you know, we went into an ice age prior to the landmass, going back how many billions of years? Who knows? But and basically, what that did was it lowered the gravitational field on this side of the planet in Asia, and allowed the volcanoes to grow from the ocean floor and push up through the surface of the ocean and basically create the first original landmass. You heard it here on YouTube University. So my name's John Shaughnessy. I wrote the book Pyramid Gravity Force. I got a bunch of laws of gravity. This is my third law of gravity. I just gave you my equation, and actually kind of meshes with my fourth law of gravity, which I'm not going to get into right now. Not with this. I just wanted to show, basically give people the a good visual on what's going on with your planet, you know. And there's a balancing mechanism on this planet that's been overlooked for you know, for a long time, since the last ingenious group of human beings that ran the planet or were on the planet at a technologically high state of existence. So with that, any questions, give me a buzz. You know, hit me up with some questions, get some comments. You know, want to be critical, whatever, do whatever you want. You know, I can. I'm 10-0 as far as arguments on this theory. It's going up against scientists, physicists, geophysicists, you name it. You know, and it's not an airy theory like quantum mechanics, relativity, or the grand unified field theory. This here is physical evidence right here. This is the planet. It's you know, mass over here equals mass over there. It's really basically pretty simple stuff. It's very, very common sense. If you can explain it to a 2-year-old, it's a good theory. And this is basically, you know, this is right at the level of maybe you know, maybe 1-year-old. And it's a very unique, and it's relative. Not to, just not saying those other theories don't have some meat and potatoes, but a lot of it is you have to believe. You have to like believe this is happening and believe that's happening. Well, right here, you don't have to believe nothing. You can see it happening. You can taste it. You can walk on it, touch it, feel it, smell it. And if you want, you can go eat it too, All righty, over and out. Thanks for watching.